Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 Problem of the Week video. And this one is using the Cofunction identity and casework, which is pretty hard to solve the problem. So without further ado, let's get on with the video. This is AMC 12A Problem 19 of the year 2021. How many solutions does the equation sine of pi over 2 cosine x equals cosine of pi over 2 sine x have in the closed interval 0 to pi? And the answers are 0, 1, 2, 3, and 4. So this question is asking you how many solutions does this have, and it gives you the interval from 0 to pi. So the first thing we must know is what does the graphs of sine and cosine look like in the interval of 0 to pi. Okay, so this is what sine looks like. It starts from 0, and then at pi over 2 it goes to 1, and then it comes back down to 0 at pi. And then for cosine x, it starts from 1, it goes down to 0 at pi over 2, and then goes down to -1 at pi. Now, to solve this problem, we have to first simplify, and we can use the cofunction identity, which basically states that the cosine of theta is going to be equal to the sine of pi over 2 minus theta. So basically what this means is that if we draw a coordinate plane right here, the cosine of an angle, let's say this is going to be 30 degrees, it's going to be the x value, which in this case is equal to the square root of 3 over 2. And the y value is going to be equal to 1/2. So the cosine of this angle is the square root of 3 over 2. And then the sine of which angle is equal to the cosine of this value, well, we can see that if we go up to 60 degrees, this is going to be 1/2, and then the y value is going to be equal to the square root of 3 over 2. And 60, or here is pi over 2. Pi over 2 is equal to 90 degrees. So basically, this is saying that the cosine of an angle is equal to the sine of 90 degrees minus the angle. Now, using this formula right here, we can simplify the equation above. Equal to sine pi over 2 cosine x equal to sine of pi over 2, and then you minus theta, which is the angle right here. Pi over 2 sine x. We also must know that if the sine of an angle, so let's say sine A is equal to sine B, then there has to be two things that are true. So the first thing is that the angle, they have to be basically the same angle but like different variations. So we know like on a unit circle, for example, if you have one angle right here, and if you add a unit circle to it, so like if you go around another circle, you get the same angle, except it is just going to be written differently. So for example, if this is going to be pi over 4, then you add 2 pi, and then you get 9 pi over 4, which these two are the same, but they are just written differently. So it is saying that if the sine of these two angles are together, they don't have to, it doesn't mean that the angle has to be the same, but it has to be like the same variation of the angle. So it has to be equal to the second angle plus a certain amount of circles, or 2 pi is one circle, so we don't know how many circles, so that would be 2 pi k, where k has to be an integer, or else it wouldn't be a full circle. And then the second one is that a has to also be equal to pi minus b plus 2k pi. So basically what this means is that right here in a unit circle, if this is the angle, then it must also equal pi minus the same angle plus 2 pi k, because these two are also going to be equivalent since these two angles are going to be the same. Now that we know that, we can put it into casework where this will be one of the cases and then this will be the second case. So the first case, using that a would equal b plus 2 pi k, and we can see that right here, why are we using this? It is because this is sine of a certain value, or a, is equal to the sine of a certain value of b. So this would have to follow these two identities. So the case one right here, it would equal pi over 2 cosine x, which is the a value right here, has to be equal to pi over 2 minus pi over 2 sine x, which is this angle right here, or the b, and then you plus 2k pi. So we can simplify this by adding the pi over 2 sine x over. It would be equal to pi over 2 cosine x plus pi over 2 sine x. Now we just simplify this even more by getting rid of the pi over 2. Okay, so we stop right here. And the thing we must know about sine and cosine is the range of sine and cosine. So sine, for the value of sine has to be greater than -1 or less than 1, because that is the range of sine if you're going all the way down to make a full rotation of sine. And then for cosine, it is going to be the same. The lowest is going to be -1, and the highest it can reach is going to be 1. So what does this mean for cosine x plus sine x? Well, the lowest is -1. It can't reach -1, and this can't reach -1. So the thing for sine x plus cosine x is going to be, the lowest is going to be -2, but it can't reach -2. And the highest can't be 2, but it gets as close to 2 as possible. So now that we know that means 1 plus 4k right here, these two are equal. 1 plus 4k is equal to sine x plus cosine x. It has to be max of 2 and a minimum of -2 without reaching it. We can see that we already know k is an integer. Right here, we have to determine that k is an integer. So because k is an integer and it has 1 plus 4k has to be between -2 and 2, the only possible value of k is going to be 0. And then so we plug that in, since this is going to be the only possible value of k that satisfies this equation. So if k is equal to 0, then cosine x plus sine x is just simply equal to 1. So we can square both sides and it will still be equal. So if we square both sides, cosine squared x plus sine squared x plus 2 sine x cosine x is still going to be equal to 1. But note that right here, when we were looking at the answers and what the answers gives us, there's going to be an extraneous root because we squared it. Cosine squared x plus sine squared x is equal to 1. So 1 plus 2 times sine x cosine x is equal to 1. And we get that 2 times sine x cosine x is equal to 0. So this is an identity that 2 sine x cosine x is equal to sine of 2x. And since this is equal to 0, what part of sine is going to be equal to 0? Well, that is going to be where it equals pi or 2 pi or 3 pi. So 2x is going to be equal to k pi. And we got this from looking at like the sine diagrams. And then so x is going to be equal to k pi over 2. Possible values for x where this is satisfied is that x can either equal 0 or pi over 2. Well, why is this? Well, it is because, so basically, going back to this part right here, sine of 2x has to equal 0. And in this closed interval, 0 to pi, the only places that it can equal 0 is either 0 or pi. Angle right here has to be either 0 or the angle has to be pi. And when we plug that in, we get x is equal to 0. And then if x is equal to pi, we get that this is 1 rotation over, so 1 pi over. So you're going over 1 pi, so k would equal 1, and then x would equal pi over 2. Now we can't. And then so these two are the possible solutions for this first scenario. So the second scenario, which is right here, a is equal to pi minus b plus 2 pi k. We just plug the same thing in. So a is equal to pi over 2 cosine x is equal to pi minus pi over 2 minus pi over 2 sine x plus 2k pi. We know that from the first part, we can see that k is equal to 0. From right here, we can see that k is equal to 0. So we can just simplify this even more. And then we get that cosine x minus sine x is equal to 1. So basically, for this to happen, x has to be 0. Why? Well, when we look at the graph, when cosine x is equal to 1, it is when the x value is going to be 0. So 0, 1. And then right here, the x value is 0, 0. So 1 minus 0 is going to be 1. So this is where we get that this is going to be 0. And this is the only possible solution because it has to be cosine x minus sine x. If we did right here, if this was the 0 and this is 1, 0 minus 1 is actually -1. So this can be the only solution for this one, and this is the only solution for here. So since the zeros are the same, then the only two possible solutions are 0 and pi over 2. Looking at our answer choices, we can see that the answer is going to be C, 2.